Welcome to Evolve demo with HP WAN controller. Evolve is a northbound application which facilitates SDN network design, provisioning, simulation, and automation. Upon secure authentication, you'll be presented with a home page, allowing you to access various tools in the suite, such as Dashboard, Design, and Control. Dashboard gives a comprehensive visibility of control, data, flow, and resource utilization of your network. You can also see the details log of the events occurring in the controller. Now to the Design tool. Design tool allows you to sketch a network design, pre-stage, and provision it. The canvas can import a physical site layout as a background image and maps the device's icons on top of it. In this case, we have simulated the HP's OpenFlow switches. We'll now define the core and access switches, position them respectively in the layout. Now we'll define the host, position them next to the access switches. And now we'll add the interswitch links between the core and the access, and also connect the host to the access switches. The canvas allows the network provisioning straight from design to implementation, reducing the time and complexity. Once the canvas is ready, you can add a security policy to determine which host should be allowed to communicate with each other. In this case, we have denied ICMP traffic between host 1 and host 3, and TCP traffic between host 2 and host 3, which is visible by red dotted line. You can now push this canvas into physical network topology, or PNT. As you can see, the created network is now visible in HP WAN controller and also in the Evolve viewer. Right-click on the switch to get the details of the flows, which are automatically created due to policy defined between the hosts. This all comprises the Design tool. Now to the Control tool. The Control tool provides the simulation of physical network in a virtual environment. After creating a PNT from the canvas, you can simulate the PNT in a simulated network topology, or SNT. In the real life, you can take a snapshot of a live production environment in PNT and automatically create an accurate simulation of this network in the virtual environment, or SNT. This allows you to test changes virtually prior to the production deployment. In SNT, we can simulate changes and get Evolve to implement those changes in the middle of night with no human intervention. A policy is a user request and a rule is a live policy implemented in the network. Here we have PNT and SNT policy and rule bases. Let's take a look at the policy base. You can add a security policy by browsing a change request or integrate it with the external change management system. We can also add policies statically, validate them, and add them in the policy base. Let's see how we can dynamically add a policy by importing a change request form and test it against the compliancy logic. As you can see, policy ID 931 is injected from a change request imported. We can also create the policies statically. Upon definition, we can validate the policy to test the compliancy of the policy against predefined logics. The compliance in this case is whether the policy is redundant or not. So as we can see, the policy ID 932 is statically created and will validate it against the compliancy logic, whether it's duplicated in the policy base or not. Once the policy is validated, you can schedule it to get implemented in the middle of night. Once scheduled, the policy will be moved to Scheduled Policy section. You can now push the policy manually. By selecting Push to PNT, the policy gets deployed in the production network and becomes live as the rule on a controller. This all comprises Change Management tool. Now let's discuss a use case where we'll upload a static flow pusher app in the HP WAN controller, which will disable the reactive flow forwarding of the controller by enabling the proactive flow forwarding control by the static flows injected. We'll create a mininet with linear topology. As you can see, the host 3 can ping host 4 due to reactive flow forwarding of the controller, which is enabled by default. Now we'll browse our app and upload it to the controller. As you can see, the app is uploaded and deployed to the controller. We'll recreate the mininet to do the ping test again. As you can see, the ping has stopped working now, and we need to add static flows to enable the flow forwarding. In the static flow pusher, we have to define the number of match and action parameters. So in our case, the match parameter is input and action parameter is output. Once we add the flows, we can right click on the switch and see the flows on the switches. We can now test if the ping is working now due to the proactive flows inserted. The next app is Flowrector. In a provision network, upon the user request for a specific source, destination, and protocol, the Flowrector can auto-compute the multiple paths available. As you can see, there are a few paths generated. Each path has its own cost and metric, which is calculated and demonstrated. Upon the selection for a specific path based on the cost of the metric, the Flowrector can auto-create the respective flows required to implement the given path. In case the traffic engineering is enabled, the Flowrector dynamically monitors the path and can do the failover between the paths. As shown, the switches have been added with the respective flows to enable the specific path from source A to destination B. This all comprises Flowrector. The last module is Netliner, which allows dynamic DDoS detection and mitigation. As shown here, we can detect heartbleed attack, and upon attack detection, Netliner can auto-create a firewall policy, do a compliancy check, and implement in the live rule base. This all comprises Evolved.